There is a discovery from 1831 that produces essentially all the electricity on this planet, and there is a working version of it sitting inside every dead appliance in your shed. Pull the motor out of a broken treadmill, spin it backwards, and it stops being a motor and becomes a generator. Not a modified motor, not a converted one. The same object, unchanged, doing the opposite job, because those two machines were never actually different. And one honest thing before we go a step further, because this is the claim that gets made badly all over the internet, and I am not going to make it badly here. The motor will run for decades, because there is no chemistry inside it and nothing to degrade. That part is genuinely true, and it is why this is worth building. But the electricity is not free. Something has to turn that shaft. Wind, falling water, a bicycle, your arm. What you are building is a converter, not a source, and anybody who tells you otherwise is about to waste your weekend. I will come back to that at length, because there is an entire category of videos built on the opposite claim, and it is worth understanding exactly why every one of them is wrong. If you are enjoying videos like this, hit the like button, because these take a great deal of work to put together, and subscribe so you do not miss what is coming next. Let me start with the thing that makes this possible, because most people have never been told it, and it changes how you look at every appliance you own. A motor and a generator are the same machine, not similar, not related. The same. Put electricity in, and the shaft turns. Turn the shaft, and electricity comes out. There is no difference in the hardware. No modification, no rewiring, no switch to flip. The identical object does both jobs, depending on which end you drive. Engineers call this reversibility, and it is one of those facts that sounds like a technicality until you follow it through, because it means every dead appliance in your shed contains a generator. The treadmill nobody uses. The broken washing machine, the scooter with the flat battery, the cordless drill with the dead pack, the printer somebody put out on the curb, every one of those has a motor in it, and every one of those motors will produce electricity if you spin it. Once you know that, you stop seeing scrap and start seeing components. Now, why does the same object do both jobs? Because the explanation is genuinely satisfying. In 1831, Michael Faraday demonstrated that moving a magnet near a coil of wire causes a current to flow in that wire. No contact, no connection, nothing between them but air. The important word is moving. A magnet sitting still does nothing at all. And there is a companion effect that had been discovered a decade earlier. Run a current through a wire sitting in a magnetic field, and that wire experiences a force. It gets pushed. Those two effects are the same relationship read from opposite ends. Motion plus magnetism gives you current. Current plus magnetism gives you motion. So a machine built out of magnets and coils will run either way, because the physics does not care which one you feed it. Push electricity in, and the coils are forced around by the magnets, which is a motor. Force the coils around by hand, and they generate current, which is a generator. Same magnets, same coils, same bearings, same everything, which is why every power station on Earth ends in the same step. A coal plant burns coal to boil water to make steam, to spin a turbine, to turn a magnet past a coil. A nuclear plant splits atoms to do the same. Gas, hydro, wind, all of them differ only in how they get something spinning. The fuel changes, the last step never does. There is exactly one common exception, the solar panel, which works on entirely different physics. Everything else on the grid is Faraday. Now, let me deal with a thing you have almost certainly seen, because if you searched anything about magnets and electricity, you have been shown it 100 times. The magnet motor, the pitch is always the same. Arrange permanent magnets in a particular pattern with a rotor and a stator. Angle them just so, and the rotor will begin turning and keep turning forever, powering your house for nothing, and it has been suppressed, obviously, by somebody. Every one of those devices spins. Not one of them keeps spinning. And the reason is worth understanding properly, because it is not a matter of nobody having found the right arrangement yet, it is a matter of what a magnetic field actually is. A permanent magnet does not contain a supply of energy that runs down. It is not a battery, its field is a static, unchanging condition of the space around it. And it will sit there being magnetic for a very long time without doing anything at all. Think about what that means for a rotor going around a circle. As the rotor turns, it passes regions where the magnets pull it forward and regions where they pull it back. And a static field has a property that decides the whole argument travel all the way around any closed loop through it, and the pulls forward and the pulls back cancel out exactly, net zero. That is not an engineering limitation. It is what it means for a field to be static. So you can absolutely build one that jumps, lurches, and turns several times when you flick it. That is real. And it is the energy you supplied with your finger, plus whatever the magnets stored when you assembled them against their own attraction. And then it stops. It always stops. It stops in the workshop of the person who built it, off camera, about 90 seconds after they finished filming. Nobody suppressed it. There is nothing to suppress. Magnets are sold openly by the ton. The arrangement is not secret. And any physics department in the world would be delighted to demonstrate one working if it could. Which brings me to the part I find genuinely worth saying. The impulse behind those videos is not stupid. Somebody looks at a magnet, feels a force with no wire and no fuel attached, and thinks there must be something to take from that. They are right that there is something remarkable there. They are just one step away from the thing that actually works. Because the same magnets, in the same motor, arranged exactly as they already are, will produce electricity all day long as something turns the shaft. That is the difference between a machine that makes energy, which cannot exist, and a machine that converts it, which is the foundation of the modern world. So let us build the one that works. The first decision is which motor, and this is where most people fail before they start. You want a permanent magnet motor. Inside it there are actual magnets, fixed, permanent, always magnetic, and that matters enormously, because it means the machine has a magnetic field the instant you start turning it. Nothing has to be switched on, nothing has to be energized. Spin it, and voltage appears immediately. The best source by a wide margin is a treadmill. Home treadmills use permanent magnet DC motors, typically rated somewhere around 90 to 260 volts DC, and between 1.5 and 3 horsepower. They are built for continuous duty. They have decent bearings, and they have a flywheel and a pulley already fitted, and they are given away constantly. A treadmill is bulky, unfashionable, expensive to move. And the moment the electronics fail, the whole thing is scrapped to its owner. The motor inside is the valuable part, and it is the part nobody wants. Check marketplace listings, check curbside collections, and check the free sections. $25 is a generous budget, and plenty of people pay nothing. Other good sources are electric scooter motors, wheelchair motors, and the motors from cordless power tools, all of which are permanent magnet. Now the ones that will not work, because this is where the disappointment lives, an ordinary AC induction motor, the kind in a washing machine, a bench grinder, a pool pump, or a workshop fan, has no permanent magnets in it. Its magnetic field is created by electricity flowing in the stator, which means it needs to be energized before it can generate anything. Spin one of those with a drill and you will read essentially nothing. It is not broken, it simply has no field. There are ways to coax them into generating using capacitor banks, and they are fiddly, inefficient, and not where a beginner should start. The second failure is the one that ends more projects than anything else. Do not use a car alternator. It seems like the obvious choice. It is designed to generate, it is cheap, it is everywhere, and every scrapyard has a pile of them. But most automotive alternators do not have permanent magnets either. They use an electromagnet in the rotor called the field coil, which has to be fed current before the alternator will produce anything. And they are designed to spin at thousands of RPM under engine power. So somebody bolts one to a windmill, spins it at a few hundred RPM, reads 0 volts, and concludes the entire idea is nonsense. It is not nonsense. They picked a machine that needs to be woken up and then never woke it up. Permanent magnet motors have no such requirement, and that single property is why the whole scrap motor approach works at all. Now, the test that tells you what you have, and you can do this in 5 minutes before committing to anything. Take your motor and chuck the shaft into a cordless drill. Put a multimeter across the 2 motor leads set to DC volts. Spin the drill and read the number. That is it. If voltage appears, you have a generator. If nothing appears, put that motor back in the scrap pile. Now do it properly, because this reading is the single most useful number in the whole project. Every permanent magnet motor has a characteristic figure expressed in volts per 1,000 RPM. If your drill runs at, say, 1,000 RPM, and your meter reads 70 volts, then your motor makes roughly 70 volts per 1,000 RPM. That number tells you everything about how to gear the machine, and I will come back to it. Write it on a piece of tape and stick it to the motor. You will be glad you did. Now, what turns the shaft? Because that is the actual question, and it is the one that decides whether this is a toy or a power source. Wind is the classic answer. A set of blades, a tail to keep it pointed, and a tower. It is the most romantic option, and it is also the most demanding, because wind is intermittent, gusty, and hard on equipment. And a badly built turbine is genuinely dangerous when a storm arrives. And there is one thing about wind that decides more than any other, which almost nobody accounts for before building. The power available in wind rises with the cube of its speed. That is not a gentle relationship. Double the wind speed, and you get 8 times the power. Have it, and you get an eighth, which means average wind speed is close to meaningless as a planning figure. Because a site that spends most of its time at gentle breezes and occasionally gusts hard is producing almost all of its energy during those gusts. It also means height matters enormously, because wind speed increases with height above the ground and above obstructions. A turbine on a short pole behind a house is sitting in turbulent, slowed air, and it will disappoint you no matter how well you built the generator. The standard guidance is to get the rotor well clear of anything upwind of it, which usually means a taller tower than people expect and than they want to build. So, if wind is your plan, the honest first step is not the motor. It is finding out what your site actually does, ideally with an anemometer left in place for a few weeks, because most people badly overestimate the wind where they live. Falling water is far better if you have it. A stream with a drop runs continuously, day and night, in every season. And microhydro produces vastly more over a day than an equivalently rated wind or solar setup. If you have water with a genuine vertical drop on your land, that is the best thing you can do with a scrap motor by a wide margin. A bicycle is the most immediate. Mount the bike on a stand, run a belt from the rear wheel to the motor, and you have a generator you can test in the kitchen this afternoon. The output is small, because a person is not a powerful engine, and it is a superb way to learn the system. And a hand crank is the simplest of all, and it is genuinely useful for emergency charging. Whichever you choose, the mechanical problem is the same, and it is gearing. Your motor wants speed. A wind rotor, a water wheel, or a bicycle wheel turns relatively slowly. So you need a step up between the two, using pulleys, and that ratio is where the volts per 1,000 RPM figure earns its place. Here is how to work it out. Suppose your motor makes 70 volts per 1,000 RPM, and you want to charge a 12-volt battery bank. You need enough voltage above battery level for current to flow, so aim for perhaps 18 or 20 volts under load, which is around 300 RPM at the motor. Now measure your source. If your water wheel turns at 100 RPM, you need a 3-to-1 step up. If your bicycle wheel turns at 300, you may need very little at all. Buy 2 or 3 pulley sizes rather than guessing. They cost a few dollars each. Swapping one takes 10 minutes. And the difference between a well-geared machine and a badly geared one is enormous. And here is the tuning mistake almost everybody makes. Tune for watts. People adjust until they see the highest voltage on the meter and stop there, and then wonder why the battery charges so slowly. Watts is voltage multiplied by current, and the gearing that produces the biggest number on the voltage scale is very often not the one delivering. The most power into the battery measure both. Keep the setting that gives the best product of the two. Now the electrical side, which is short but not optional, you need a blocking diode between the motor and the battery. Without it, when the wind drops or you stop pedaling, the battery will happily push current back into the motor and spin it as a motor, quietly draining itself. A diode costs $1 or $2 and prevents that entirely. You need a charge controller to stop the battery being overcharged. Any basic controller suited to your voltage will do the job. You need a fuse at the battery, and this one is genuinely not optional, for reasons I will cover in a moment. And you need somewhere for surplus power to go if you are using a source that cannot be switched off. This matters enormously for water, and it matters for wind. If your batteries fill and you simply disconnect the load, a water wheel keeps pushing and a wind rotor keeps spinning, and the generator can overspeed and destroy itself, or in the case of a turbine, run away entirely. The answer is a diversion load, meaning the controller sends surplus power somewhere harmless, usually a heating element. Many people route that into a water tank, which turns a safety requirement into free hot water. Skip that step on a water or wind system, and you will eventually destroy the thing you built. Now, the arithmetic, because you deserve honest expectations. A person pedaling hard produces somewhere around 100 to 150 watts of mechanical output, and after losses you are collecting perhaps 75 to 120 watts of electricity. An hour of genuinely hard work gives you roughly 1/10 of a kilowatt hour. A small wind turbine on a decent site, with a scrap motor and homemade blades, realistically produces tens of watts on average across a month, with bursts far higher on windy days and long periods of nothing. A microhydro setup on a stream with 3 meters of drop and a modest flow produces somewhere around 29 watts continuously, which sounds unimpressive until you multiply it by 24 hours and get 7/10 of a kilowatt hour every single day. Without exception, in December, as much as June, that comparison is worth sitting with because it explains why people with water on their land are so evangelical about it. The rate is small and the total is large because it never stops. Now, what that actually runs? At the small end, 1/10 of a kilowatt hour a day covers phone charging, LED lighting for an evening, a radio, and a laptop occasionally. At the larger end, several hundred watts continuous covers a refrigerator, full lighting, a water pump, and the general background draw of a small off-grid building. What none of it covers is electric heating, electric cooking, or an electric kettle, because those loads are measured in thousands of watts and there is no arrangement of scrap motors that gets you there. So the honest position is that this is a genuine power source for a cabin, a workshop, a shed, or a backup system, and it is not a replacement for a grid connection at ordinary household consumption. A motor used as a generator is not optimized for the job, and purpose-built lower PM generators outperform them noticeably. What a scrap motor gives you is a functioning machine for almost nothing, and that trade is usually worth it. Now the safety, and there are 3 things that genuinely matter. Fuse the battery at the battery. A lead-acid battery can deliver hundreds of amps into a short circuit, and an unfused cable that chafes through against a frame will glow red hot and start a fire. This is the single most common serious mistake in amateur off-grid work. Guard the mechanics. A spinning shaft, a belt, and a pulley will catch a sleeve, a glove, or long hair without any hesitation, and a belt drive under load has no sympathy. Build a shield over it before you run it, not after. And never connect any home-built generator into your house wiring in a way that could push power back onto the utility lines. Backfeeding a grid can kill a lineman working on what he believes is a dead circuit. Tying anything into a house is a job for a qualified electrician with proper transfer equipment, and there is no shortcut worth taking there. Beyond that, the voltages involved in a small system are modest, and the risks are ordinary workshop risks. So this weekend, here's what I would do in order. First, go and find a motor. Look in your own shed before you look anywhere else. Then check free listings for a treadmill. This costs nothing and takes an afternoon. Second, do the drill test. Chuck the shaft, put a meter on the leads, spin it, and read the voltage. 5 minutes, and it tells you immediately whether you have a generator or a paperweight. Third, work out your volts per 1000 RPM and write it on the motor with tape. That single number will save you hours later. Fourth, before building anything permanent, mount the motor on a bench and drive it with a drill through your intended pulley ratio, with the diode, the controller, and the battery connected exactly as they will be, to watch the current going into the battery. That bench test is the step people skip, and it is the one that reveals a wrong gearing ratio in 10 minutes instead of after a week of building a tower. And fifth, only then decide what will turn it. Look honestly at your land. Is there wind, or do you only think there is? Is there water with a genuine vertical drop? Because the site decides this project far more than the equipment does. Now, one last thought, and it comes back to where we started. Somebody watching this has a magnet motor half built in their garage right now, and has spent real money and real weekends on it, and is going to be annoyed with me. I would say this to them: the instinct was right. There genuinely is something extraordinary about holding 2 magnets and feeling a force with no wire and no fuel involved. That feeling is what pulled Faraday into this in the first place. The mistake is only in what you ask that force to do. A magnetic field will not push a rotor around forever because it has nothing to spend, but it will convert motion into electricity endlessly without degrading. for as long as anything at all is turning the shaft. That is not a lesser version of the dream. That is the dream, and it is the reason every light in your street is on tonight. So the question worth arguing about in the comments is this one. You have a scrap motor and a weekend. Wind, water, or pedals? Which are you actually building? And what have you got on your land that would turn it? Because most people watching this genuinely have one of the three sitting outside and have never once measured it. Tell me in the comments.